Okay, so in the first part of this lecture, we talked about primarily the epidermis. So we were talking about this avascular layer, right, of our keratinized stratified squamous epithelial cells. So now we're going to get into what's called the dermis, right? And remember that the skin consists of the two layers. It consists of the epidermis and then the dermis. And so this part of the lecture, we're going to focus on the dermis. I'm going to tell you it's composed primarily of dense irregular connective tissue, but we're going to kind of break this down because there are two parts to the dermis, and one part of the dermis, this papillary region, is actually going to have more areolar connective tissue. But the reticular layer down here, which makes up the majority of the dermis, about 80% of the dermis, is going to have this dense irregular connective tissue. So that's why that's here. But we're going to break that down a little bit. And again, there are all kinds of fibers in the matrix that are going to help bind the body together. We're going to talk about some of these fibers and why they're important in terms of the tough collagen fibers, but then we have these nice elastic fibers as well. So the dermis, actually, believe it or not, makes up the hide that's used to make leather. So when you are wearing a leather jacket or a leather belt, you're actually wearing the dermis of an animal. Whether or not that creeps you out or not. But yes, you are actually wearing the dried out dermis of an animal. And then when we talk about the dermis, it also is going to be vascular this time. So remember that the epidermis is avascular, but the dermis is actually quite vascular. So again, it's got a lot of blood vessels running through it. And remember that it's the dermis that actually supplies nutrients, right, to the epidermis as some of those nutrients kind of diffuse from cell to cell into the epidermis. So so the dermis is very vascular. This is a big, big difference. And obviously, I've emphasized this a number of times. Hint, hint, you know you're going to see that on the exam, okay? There is going to be something about the fact that the epidermis is avascular. It has no blood cells running through it, and the dermis is very vascular, okay? And then, of course, there's nerves and lymphatic vessels running through here as well. And we'll actually get into and talk about when we get into the accessory structures, some of these nervous structures like the Meissner's corpuscles that you'll see here and Pacinian corpuscles and things like that. And then some of your just free nerve endings. And then you'll see the dermis. This is also where you're going to find all of these accessory structures like the hair follicles, oil glands, and sweat glands. So here you can see here's your oil glands. I'm just kind of pointing them out now. So because I know that you're getting them in lab as well. Here's a sweat gland here. So just to kind of review some of those from lab. And then again, like I told you, we're going to break down the dermis into these two major regions. So there's the papillary region, this region that has all these papilla, right? These are these little papilla structures, these finger-like structures are your dermal papilla. And then, so this region here is going to be the papillary region of the dermis. So let me see if I can get my pen here. So this region, really, right here, from here on up is going to be this papillary region. And then here, from here on down, will be the reticular region, okay? So hopefully that kind of helps you out there. So again, here is your epidermis. Remember that we just talked about last lecture? And again, you can really see all those, the cells look dead, right? They're these dead keratinized stratified squamous cells. And then, okay, here again are some of still the living cells of the epidermis, right? But here is the border between right here, the epidermis and the dermis. And so you can see here is this papillary region, okay? Here's the papillary layer. So you can see these dermal papilla, okay? And then here is the reticular layer. And you can actually see, if you look at it, that the connective tissue here looks different. So again, you may recognize this as that dense, irregular connective tissue here, right? And then if you looked a little bit closer here, you would see that the papillary region actually has more areolar connective tissue. So again, just kind of a little heads up while we were actually looking at that slide. So again, we're going to get into each of these. So remember that papillary region that I just showed you is going to be the top 20% of the dermis, okay? I mean, an estimate, right? And it's going to consist of this areolar connective tissue. So when you looked underneath the microscope, which you didn't do in labs, sorry, I'm so used to in-person labs. So when you looked at the microscope slides, right, you probably actually looked at some of the areolar connective tissue when you were for the histology slides. That was from the dermal papilla, okay? So again, if you looked in here, that there's mostly areolar connective tissue in there with these collagen and elastic fibers, as well as it's going to be very vascular. So there'll be a lot of blood vessels in here. And if you think about it, it makes sense, right? That we have these dermal papilla with these blood vessels running through here. And that way, then it kind of maximizes our surface area by which, again, nutrients can be passed on from cell to cell, from the dermis into the epidermis. So you'll see that these dermal papilla are quite vascular. And it makes sense, right? Because it makes sense that you want to maximize your surface area to be able to share nutrients with the epidermis. Okay. So, and again, these, the loose fibers inside the papillary layer, so the areolar connective tissue is much more loosey-goosey, right? So these loose fibers, and that actually allows for certain immune cells, phagocytes specifically, to kind of patrol for microorganisms in this layer. And again, so these dermal papilla, that we talk about are these finger-like projections that you see. So here you can see, here's your dermal papilla here. If I can outline some of them here. Those are your dermal papilla, okay? And they look like these little finger-like structures. Again, these projections are very vascular. So they contain what are called capillary loops. So lots of capillaries that are going to help, again, feed the epidermis ultimately, right? Because as cells of the dermis are, again, absorbing those nutrients will diffuse, right, across into the epidermis. And so there are also quite a few free nerve endings. So, and these free nerve endings, let me see if I can go back and show you a picture of some of these free nerve endings. Here, so in here you can see here are these free nerve endings right here. And these free nerve endings are important because they're going to provide sensations, the sensations that you feel, like heat and cold and pain, tickle, your itch, you know, when you feel itchy. So there's lots of those free nerve endings that are responsible for those sensations. Now, what's interesting is that these free nerve endings can actually only convey one type of information at a time. And so that's why if you, for example, have mosquito bites and you're like scratching them, you know, I always take, if my kids are doing that, I take an ice pack and I put it on their mosquito bite. And then those nerve endings will convey cold instead of itch. They can only convey one type of information at a time. So by basically adding cold, you're kind of tricking those nerve endings into focusing on just the cold sensation. And then we do have touch receptors, and they're called Meissner's corpuscles. Again, you're going to look at these in lab. So, but I'm just going to go back and show you them here. So if you look in the dermal papilla here, that's where you're going to find these Meissner corpuscles. And these Meissner corpuscles kind of look like these, crazy little structures with these, with the nerves wound up in here. So it looks like a little capsule, okay? So you'll see these right underneath these dermal papilla, okay? So those are your Meissner's corpuscles. And again, those are touch receptors. Sorry if I didn't mention it. Those are touch receptors. Okay, so here, the other thing that you're going to see is we have these things called dermal ridges. And these dermal ridges will oftentimes be responsible for the epidermal ridges that you can see. So you can see this pronounced epidermal ridge. And our really pronounced epidermal ridges, again, thanks to, if we go down here, our dermal ridges here, our dermal papilla, are going to be because these really pronounced epidermal ridges will actually be what produces your fingerprints ultimately. So these really pronounced epidermal ridges will be found like on your fingertips. And again, that's responsible for your fingerprints, which is pretty cool when you think about it. So you can kind of put things in perspective from the microscopic level up to, you know, the more macro level that you can actually see, right? So again, in thick skin, like your fingertips, the dermal papilla are going to lie, again, on top of these dermal ridges, and they're going to give rise to these epidermal ridges. So here you can see here's kind of these dermal papilla on this dermal. So here's kind of the dermal ridge, right? Here's what we call the dermal ridge. It goes up and down like this. And then you have these papilla, right? You have the papilla within that. So that's a little more nitty gritty than, you know, you needed to know. But what I wanted you to really see is that these dermal ridges give rise to the epidermal ridges. And then those ultimately give rise to our fingerprints, okay? And so these epidermal ridges collectively, we'll oftentimes call them friction ridges. And it makes sense, right? Because you're kind of increasing your surface area with this folded structure. Anytime you see anything that's folded or feathery, you are increasing your surface area. And so here you're increasing surface area for friction. Okay, and so this really enhances like our gripping ability. That's why we have that on our fingertips. It also helps to contribute to an increased sensation of touch, right? Because we have more surface area for those touch receptors and nerve endings. And then we even have, check this out, sweat pores, right? In our fingertips here. So pretty crazy, all of the things that you can find just in your fingertips. Okay, so the next layer is going to be what's called the reticular layer. So remember here, the upper 20% is the papillary region, and then the lower 80%, okay, is going to be this reticular region. That makes up, again, about 80% of our dermis. And here it's going to be mostly that dense, irregular, wow, I just got crazy there with the pen. But it's going to be mostly this dense, irregular connective tissue, okay? And so you can really see that a few slides ago when I had this one up here. You can really see this dense, irregular connective tissue, which is why I like that slide. So again, that's making up that lower 80%. And you're going to see that you have these collagen fibers that in this layer that are really going to add strength and resiliency. But remember, those collagen fibers are not going to be in a regular pattern. So they're going to be in that irregular pattern. So that way then they can resist pulling in different directions, which is important on your skin because, you know, your skin, unlike like a tendon, right? It is not going to be pulled in the same direction all the time. So that's why we have these this dense irregular connective tissue with these collagen fibers, and we'll have a bunch going, one direction here, and then we'll have a bunch maybe going this direction here, and then a bunch over here going this direction. So again, they're really helping. Sorry, now I'm just coloring on my words there, but now you can kind of see how they would help resist again, tearing in all different directions, okay, on the skin, which is really important. So again, that's why that dense irregular connective tissue is important in that layer. And then again, also those fibers have to bind water, which really helps to keep our skin hydrated. And then we also, of course, have elastin fibers as well to help provide a little stretch recoil. So again, as we stretch the skin, right, it doesn't just stay stretched. Well, I mean, as we get older, right, we lose some of that elasticity of the skin as some of those elastin fibers break down. But, you know, in younger skin, right, if you stretch your skin, it bounces right back. It recoils right back because of these elastin fibers. And then again, it's packed with all these lovely things like sebaceous glands, these oil glands. Sudoriferous is what we call them, right? In lab, sudoriferous or sweat glands. So here's one right here with the duct going all the way up to the surface. And then lots of blood vessels, lots of nerves in here. And then we even have some fat, a little bit, but mostly, again, you're getting into the sub-Q layer there. And then some hair follicles as well. So here you've got your hair follicle. Okay. And again, so when we talk about this layer, the reticular layer, it's going to provide both strength, right? Those lovely collagen fibers are going to provide some strength. And then we also have these two terms that you kind of have to get to know for especially anatomy and physiology: extensibility and elasticity, okay? Extensibility, you may want to write this down here. Extensibility is simply just the ability of something to stretch, okay? So not necessarily its ability to recoil, right? Just its ability to be able to stretch. That's extensibility. Elasticity is its ability to recoil or return to its original shape after stretching, okay? So this is its ability to stretch. This is its ability to return to its original shape after stretching, okay? And so it's important that the skin has both, right? So we can stretch it and it has this elasticity, it bounces back. So you can picture this like, you know, a piece of bubble gum. A piece of bubble gum is extensible. You can pull it out, but it doesn't recoil back, right? But a rubber band has elasticity. You know, you pull it and it bounces back and snaps to your finger, okay? So hopefully that kind of helps. Now, when we talk about, again, some not pathology, but, you know, some things that can go wrong in terms of some of the dermal tissues, when you typically, if you grow really rapidly in an area, oftentimes this happens during pregnancy, right? Your stomach expands fairly rapidly, and the skin is stretched very rapidly, and kind of to an extreme level. Oftentimes, you can get what's called dermal tears, where literally the dermis gets a tear in it as that skin's stretched, and it creates what are called stretch marks. Now, these are different, right, than if you actually had like a cut through your skin into your dermis, right? Because that actually cuts through the epidermis. But these stretch marks are actually just dermal tears. They don't go all the way through the epidermis. They just go through the dermis. And what ends up happening is as the dermis heals and it, you know, comes back together in that area where it was torn, it ends up not coming back together the same way, okay? So you end up with more of this kind of connective tissue with lots of collagen fibers and things like that. And it forms oftentimes these silvery white scars that we call striae. So striae are the same thing as stretch marks. So that's why we get those stretch marks. Those are actually dermal tears. Now, interestingly enough, blisters here, right, are just an acute trauma, just a minor short-term trauma to the skin, end up being these like fluid-filled pockets that end up because you've had, again, a lot of friction of moving that dermis and epidermis against each other. And so you end up building up fluid in there, and that fluid-filled pocket will actually separate the epidermis from the dermal layers. So that's what ends up causing your blisters. Kind of interesting. Tattoos are always fun to talk about. I am a fan of tattoos, so I always like to talk about them in this class because many people don't actually know that tattooing is injecting the dye into the dermis, right? So if you were just injecting the dye into the epidermis, right, then it wouldn't stay because you're constantly sloughing off your epidermis. So for example, like henna tattoos, right? Henna tattoos are dyeing the epidermis, but eventually they're going to come off as the epidermal layers slough off, right? But now tattooing is a permanent coloration of the skin because you're actually injecting those dyes into the dermis. Okay, so really kind of interesting. This is a tattoo of maybe somebody that I might know fairly closely. And then this one is Prison Break. It was just showing kind of what it would look like tattooing all over the body. And then and just trying to appeal to the, although I think Prison Break is now old because this is an older lecture series that I created. But I have updated some things in it. And this one, I don't know if any of you, my kids love Smarter Every Day. And he does this great quick video clip on tattooing. It's only about 6 minutes. If you click on this link, you can see this. And what he does is he uses special camera equipment to be able to get up close so that you can see those needles injecting the dye into the dermis, which is pretty interesting. So of course, this is why tattoos, are a little uncomfortable when you're getting them because again, you're injecting that dye into the dermis, okay? Now, really quickly, to just as kind of an aside, if you were to, didn't like a tattoo and you wanted to have it removed, what you can do is you can have the laser removal done on the tattoo. And so what they do is they use a laser to break up the actual dye within the dermis. And as it breaks up those pigments, then the immune system will kind of clean them up, okay? But it oftentimes takes several treatments to do that. Okay, so again, in the reticular layer, you end up getting these like flexure lines here. And so I know you guys have all seen these on your hands, where you end up having kind of folds at certain joints, okay? And so this helps in terms of giving you that more mobility around that joint. Without like having your skin just kind of like falling down, like if you think about it, if you didn't have this flexure line so again, the dermis, and I should explain what it is. The dermis is going to be nice and tightly secured to some deeper structures in that area. And so what would happen is if you didn't have that, right, as you folded your hand downward, the skin would just kind of like fall off your hand as you kind of, created slack in it. And that would be really bad and kind of gross, right? So we have these flexure lines so that our skin doesn't do that, okay? And it helps to really kind of anchor it as we, use those joints, and it ends up giving us more mobility around those joints. The skin's inability, again, to slide easily for joint movement causes these deep creases, and again, really helps to like hold the skin together so you're not, gathering skin there. And again, you can see this on your hands, wrists, fingers, soles, and toes. The hypodermis, remember the hypodermis is not part of the skin. And so this is the subcutaneous layer. So here's your hypodermis. And so remember there's a lot of adipose tissue here. So they drew in all that yellow adipose tissue. But remember hypodermis is just below the skin. So again, this is the subcutaneous layer deep to the skin, okay? And so, and that's what subcutaneous means. So the hypodermis, again, hypo below, dermis, okay? And then also subcutaneous. So cutaneous, remember, is the skin. Skin is epidermis and the dermis. So sub, below, cutaneous, the skin, is what subcutaneous means. So if you're giving injections into the subcutaneous layer, this is what you're shooting for. You're shooting for that hypodermis. So hypodermis, subcutaneous, two different words, same thing, okay? Same layer, hypodermis, subcutaneous layer. again, composed of adipose tissue and then some areolar connective tissue as well in there. So let's talk a little bit about skin color because this always gets super interesting. So, and I have a video for you to watch on the biology of skin color and the evolution of skin color, which is really, really interesting. So when we look at skin color, there are 3 pigments ultimately that contribute to skin color. So we'll talk about the first one, melanin, and then there's different types of melanin, which makes it crazy. But we'll talk about melanin and then keratin and hemoglobin. Those are the 3 main pigments that contribute to skin color. Now, what's cool is our first one, melanin, okay, we've already talked about. So remember, we have these cells called the melanocytes that are going to make melanin, okay? And in humans, there are now 3 forms of melanin, okay? So in humans, we actually have what's called eumelanin, which is here. We have pheomelanin, which is here. And then we also have a new one that they just discovered called neuromelanin, okay? There's not quite as much information about that one. That one's a newer one that we've discovered. So so when we talk about melanin kind of comes in these 2 different forms. So we've got, again, the reddish yellow, which is going to be more of your pheomelanin, okay? And then the brownish black is going to be more of that eumelanin. So you don't really have to know pheomelanin or eumelanin. I just want you to know it comes in these 2 main forms. And there is a 3rd form now that they're just kind of learning more about called neuromelanin. But anyway, that melanin, okay, remember, is ultimately packaged into what's called melanosomes. Again, that's a little more than I really probably need to get into here. But remember that it's made by those melanocytes and then kind of packaged up. And it is packaged in something called melanosomes. So it's packaged up and then it's sent into the keratinocytes. So remember that the melanocytes look kind of like this. And then we have the keratinocytes that sit like this, okay? And so what ends up happening is those, again, melanocytes package up that melanin into these melanosomes and then shoot it into these keratinocytes, okay? As they move up into, the stratum spinosum layer, okay? So, and so melanin is really important because it helps to shield DNA from sunlight. So as you well know, right, UV light from the sun can actually damage our DNA. And ultimately, again, too much damage to that DNA can actually cause skin cancer, can cause those cells to grow abnormally. So again, that melanin is important for helping to protect our DNA inside our cells from sunlight. And believe it or not, the more sun exposure you have, it actually, some of you probably noticed this in the summertime. So the more sun exposure you have, it actually stimulates melanin production. So this is why you're like, oh, I got really tan this summer, okay? So just being outside more is actually going to stimulate the more melanin production. Now, what's really interesting when you get into skin color is all humans have about the same number of keratinocytes and about the same number of melanocytes as well, right? So really interesting. We have the same number of melanocytes. But what's different, okay, is the amount and the form of melanin that's produced, okay? So again, that's what forms the different skin coloration, okay? And so I always think it's really interesting to see that we all have the same number of melanocytes. It's just that some people produce more melanin than others, and some people produce more eumelanin, some people produce more pheomelanin. So for example, if you have red hair and those kind of reddish freckles, you produce more pheomelanin, okay? So again, just kind of interesting. And then freckles and pigmented moles are really localized accumulation of melanin. So again, melanin is going to be produced in the epidermis by those melanocytes. And again, the melanocytes package it and send it into the keratinocytes. And melanocytes actually ultimately convert something called tyrosine to melanin. So, they do this with an enzyme called, and this is going to be important in a minute because we're going to talk about albinism, but they do this with an enzyme called tyrosinase. And so that enzyme actually is important for converting tyrosine to melanin. So again, the UV light in sunlight is going to increase your melanin production. And again, just like I talked about, we have the same number of melanocytes in everyone, but differing amounts of pigment are produced. Okay, so let's talk about some of the other, and then again, I have this great video that talks about the evolution of skin color, and it is really cool because it talks about the reasons why we have evolved all at this diversity in terms of skin color. And it's just a very cool video. It's so cool. I'm actually going to offer some extra credit, and I have a worksheet to go with it. So you'll see that will be posted for this week. Okay. But back to kind of the basics before I digress too much. I could spend so long talking about this because it's so very interesting. Let's talk about the two other major things that impact, two other major pigments that contribute to skin color. So believe it or not, keratin is one. And for those of you that have had little kids and you fed them like too much carrots and sweet potatoes, my daughter is a great example of this because she loves like sweet potatoes and carrots and she could eat them all day. And she actually did end up getting like a little bit, obviously that this was enhanced. I just used this picture to be dramatic and someone obviously enhanced the image, but kids actually do develop, if you eat a lot of keratin, a little bit of an orange tint to your skin. Not quite this bad, but, and it's pretty cool. It's usually most obvious in the palms and the soles of the feet. So if you look on the internet, you can see pictures of like the soles of babies' feet. The nice part about keratin is obviously it can be converted to vitamin A, which is really important for vision, epidermal health. So all fun stuff about keratin. And then hemoglobin is going to be your third, believe it or not, pigment that is going to impact skin color. And so hemoglobin, right, that's that protein that's going to carry oxygen throughout your blood. So again, when hemoglobin is full of oxygen, it's going to kind of be reddish in coloration. So this pinkish hue that we get, especially for fair-skinned individuals that don't have a lot of melanin, is basically just because their skin is more transparent. So the hemoglobin actually shows through. So it's not that they have more hemoglobin, right? It's just that you don't see the hemoglobin as much here because, again, it's masked by the melanin, right? But here, this is an individual that has albinism. You can see now that pinkish hue, and you'll really see that in individuals that have albinism, which is, we're going to talk about the lack of pigment production, right? So because we're not producing any melanin, you really see that hemoglobin underneath the skin, that pinkish coloration. So, and again, please take the time to watch this. I think it's only like 20 minutes, and it is a really great, so you can click on the link from my PowerPoint, but you can also click on it. I'm going to have it posted in the actual chapter module as well. So you can click on that, and then there'll be a worksheet with it as well. Okay, so a couple of clinical imbalances, and then I promise I will try to cut this short here. So this is really cool. Excessive, well, not cool. Not cool to have excessive exposure to skin damage here. But this is an individual that was a truck driver for like 28 years or something like that. And you can see on the left side, he had his window down a lot, right? While he was driving. And you can see that he sustained like extra damage basically to the left side of his face, because basically skin damage accumulated, or sun damage accumulated on that left side after 28 years on the road. So pretty crazy. But so as you can see here, the elastic fibers, due to excessive sun exposure, actually start to clump, and this causes the skin to have this kind of leathery appearance that you're seeing right here. And then it can also depress the immune system and cause some alterations, obviously, in your DNA that could ultimately lead to skin cancer, because that UV light, again, can damage your DNA. UV light can also destroy folic acid. So this is why if you're pregnant, oftentimes they ask you to take folic acid, because that folic acid is really important for DNA synthesis. And for individuals that don't have enough folic acid, or again are outside quite a bit and that folic acid is being destroyed by UV light, then they don't have enough for their developing embryos, and this can cause all kinds of neurological issues. And then photosensitivity is just kind of our increased reaction to the sun. So there are certain drugs, you guys have probably all been on antibiotics, where they're like, don't spend a lot of time out in the sun. Again, because it just increases your sensitivity to sun damage. Okay, antihistamines can do this as well. And they cause this photosensitivity, which oftentimes ends up giving you what we call these sun rashes. Other alterations in skin color that you should know about for their clinical aspects of them. Cyanosis is just this bluish coloration that we get. It's temporary, okay, again, so we call it cyanosis or cyanotic skin. And this is when hemoglobin doesn't have enough oxygen, okay? And so because it doesn't have that red coloration, oftentimes you'll start to see the skin in those areas will actually look blue. And that's because the hemoglobin's literally not carrying enough oxygen. So for example, a baby that might have been choking and is no longer breathing and able to oxygenate their tissues as well, you'll see cyanosis there and things like that. And that's obviously an emergency. That's a child that is not, their tissues don't have enough oxygen, including, their brain tissue. So then we have erythema, which is just basically redness. So here, oftentimes when we have erythema, it's just due to maybe you have a fever and so your face looks flushed, or you have some type of inflammation. Here in this case, this is due to a tick bite, and this kind of ring formation that you see in the erythema here is oftentimes an indicator for Lyme disease. So kind of something important to know about. And then oftentimes in allergic responses. So I have kids with major allergies, and we oftentimes see this. They'll end up with, redness where they were exposed to the allergen, and then a rash. Pallor is basically just this pale color, and this oftentimes happens in anemic individuals that have low blood pressure, like if you are in a moment of intense fear or anger, and your blood flow to your extremities decreases, you can get this pallor. Or if you have something called a Raynaud's, which I actually have, you may get this in your fingers, especially when they get really cold. The blood flow to the extremities for me with Raynaud's decreases. And so you end up getting this pallor, which is this really pale coloration as those blood vessels constrict, and you don't have, again, as much of the color of the pinkish hemoglobin color there. And then, jaundice. Jaundice is just this yellow cast coloration that you get from the buildup of bilirubin. So this oftentimes happens in liver disorders, but it also happens in infants. So for example, my second born had jaundice because the liver wasn't fully developed, or it hadn't kicked in, right? So it takes a little bit to kick in. And so bilirubin is just a byproduct of our red blood cell breakdown. It's kind of part of the red blood cell recycling process. But the liver is what does the breakdown of that bilirubin. And if the liver is not quite functioning all the way yet in these infants, then that bilirubin breaks or builds up in their system. Now, what's interesting is then they found that, blue light and UV light actually will break down that bilirubin to biliverdin, okay, which is a soluble byproduct. And then that biliverdin can then be pushed out of the body as a waste product, okay? So just kind of interesting. That's why they usually take infants that are showing some jaundice and they put them under the UV lights. Or, they ask you to put your infants, take them outside to get them some UV light outside. A couple other different skin conditions. Vitiligo is just oftentimes an autoimmune disease that actually attacks the melanocytes. So you end up with a loss of melanocytes in certain areas. And of course, then the melanocytes can't produce melanin. So you have no melanin production in those certain areas. Bronzing happens oftentimes with something called Addison's disease. It's just the opposite. You end up, because of inadequate steroid hormones, your melanocytes end up producing like kind of too much melanin, more melanin than they usually would produce. So you get this kind of bronzing effect here. And then let's see, albinism is the next one. And so here in albinism, there is a lack of that tyrosinase, and that's the enzyme, right, that would turn tyrosine into melanin. So because they don't have that enzyme, there's no melanin production, okay? So that's the big thing for albinism, to know there's no melanin production. So because of that, they oftentimes, again, have that pink hue to them because the hemoglobin is showing through, okay? And then bruising. So again, the black and blue marks that you see in bruising is basically just due to clotted blood underneath the skin. So again, you damaged some of the blood vessels from the dermis by like an intense hit, right? And then those blood vessels broke in the dermis. And then again, as the blood clotted underneath there, then you ended up with that nice color, that kind of blue and black coloration. Whew. All right, so we're going to stop here and then we'll